Welcome back to AIM Research. This event is hosted by the Center for Academic Innovation and aims to act as a center for conversation, inspiration, and research to inform educational innovation of all kinds. If you have ideas for people we should invite to come join us, please do send them my way. This will be a monthly speaker series going forward with an agenda for the winter semester coming shortly. You can check out all of Academic Innovation's events at ai.umich.edu/events. Today's presentation will be recorded and posted to our CAI YouTube channel after. Feel free to submit questions for Monique using the Zoom Q&A function. I am so excited to welcome Monique today. She is at the Stanford Sociology of Education program in SHIPS and also an IES fellow. She currently studies student pathways through college as part of the Carter Research Lab with an emphasis on gender, race, and first-generation college students. She's advised by Mitchell Stevens and Sean Reardon. More general research interests include equitable math practices, charter schools, and disparities in environmental access and stewardship. Before Stanford, she was a middle school administrator and a math and science teacher. She earned a BS in human development from Cornell and a master's in school leadership from Harvard. She currently serves as the SANE co-chair and a teaching assistant for the undergraduate honors research program. Monique, welcome, and thanks so much for joining us today.
Well, thank you so much. I appreciate that. Thank you both to Trevor and Kate for planning and kind of executing this talk. I'll share my slides and we'll get started. Great. So I'm excited to be presenting on my dissertation research and hopefully have some great conversation about course choice. I should also say that I am terrible at checking the chat during a presentation. I welcome, either Kate to monitor the chat and interrupt me, or I can go through the questions in the chat at the end. Happy to do either, but I am terrible at doing it mid-presentation. So today I'm going to spend the first few minutes just establishing how my work fits in the larger work on course selection and choice and how I'm framing it. And then I'll discuss the longitudinal cohort study from which my dissertation is drawn, and the first paper that came out of that dissertation about how choice in first math courses in college can lead to inequality. And I'd love to finish with the implications for this work and the next steps for the project. So I'll start by saying that I'm currently the lab manager for Carter Pathways Lab, which has a similar focus to Michigan's Atlas program. It's a course search tool that is also a research project, and over 95% of undergraduates use it at Stanford. It provides a ton of data to answer questions about course search and selection, progression, to and through the majors, and decision-making processes. And I approach these questions about choice qualitatively and through a sociological lens. Essentially sociology is the study of inequality, and I'm interested in how inequality is maintained and mediated by organizations. In this case, how does the process of course selection contribute to stratification, particularly in the STEM versus non-STEM dynamic, where, we still see rampant inequality in, participation, degree completion, and, workplace outcomes. I also bring my background of being a middle school math teacher, as well as a math coach and vice principal to my work here. As you'll see today, I'm particularly interested in STEM pathways. So I thought I would start by reminding us how unique US higher education is. US higher education, especially in liberal arts environments, is unique in the world, and that shortly after admission, students are asked to make a ton of decisions that completely dictate their undergraduate experience. They rank dorms, they choose clubs and sports to join, they decide whether they're going to have a job, what type of job that will be, and they're asked to choose their courses. In other national systems, the course programs are set upon arrival at college. In the US, we're very committed to a system of higher education that is based on choice. And people have vastly different college experiences than by design. And we have a lot of evidence that choosing courses is actually quite complex. In course selection, you make consecutive grouped choices, and there are dynamics of choice, between the items, balancing STEM and non-STEM classes, and your initial set of choices, impacts the next set of grouped choices, and it unfolds over a long period of time. So, other things happen that influence those choices. And all of this makes the quantitative element of analysis, fairly difficult. I know that Elizabeth Brooke and Rachel Baker are doing work to, untangle that. And if that wasn't, enough complexity just in the logistics, I think that we also know that choice itself can be problematic. Barry Schwartz talks about how more choices are not necessarily better, and the more choices you have, the less satisfied you are with that choice. You know, the idea that too many choices puts the onus of that choice on the individual, meaning people blame themselves for the poor results of a choice process. And right here at Michigan, you have Aaron Seck, who just came out with this book, The Trouble with Passion, about you know, the cultural belief in pursuing your passion. And we see this play out in both career decision-making as well as major and course choice. You know, like, what are you passionate about? Find your passion. And of course, this is advice most useful to families with the resources to support passions that are less lucrative than other endeavors. You know, this narrative has a detrimental effect on students who may need college to achieve upward mobility, or who pursue domains that, you know, aren't necessarily fascinating to them, but would ensure financial stability. And I find the idea of passion is actually conflated with enjoyment in college when students are evaluating college classes. So a discouraging event in a course could make a student say, you know, maybe this isn't my passion, you know, I'm not enjoying this at all. And that, of course, you know, it happens in certain subjects more than others. And thus the narrative has important implications for STEM pathways, you know, who are notorious for having introductory courses that do not, you know, spark joy. So I also want to point out that at most colleges, especially liberal arts schools, you'll see some version of this messaging. Here at Michigan, you know, I pulled this, it states, while some students may arrive on campus with an idea about which major they would like to declare, most students usually spend their first and second year exploring various majors. Ideally, the choice of a major is the end product of a process of reflection, research, and action. If you choose a major and begin to have second thoughts, don't feel like you are stuck. Many students often change their minds about a major after they discover a different and better option. And it's the same at Stanford. This is a slide from a recent advising video to Frosh. Oh, Frosh is another word for freshman. And it's on course selection at Stanford. So the first 2 points, I think, are fairly standard. Your first year is all about exploration, and you don't have to know what you want to do. That messaging becomes complicated though. So, you know, I don't know if you've noticed, but I feel like I've noticed that I don't often hear anyone telling students that they've made a bad decision in compiling their first quarter schedule. You know, as far as the university is concerned, there are no bad courses in the exploration process. And, you know, if it meets certain basic criteria, student created schedules are rarely deemed as, you know, wrong. However, if and when students have a career or a major in mind, then the advice becomes relevant and I would say critical. Here's an example from our data. So this is a low-income student, June, who loved biology in high school. Here's his first year fall quarter schedule. So 2 introductory seminars around biology. Introductory seminars are courses especially designed for Frosh to explore a major or a domain. There's a required writing class, PE class, Frosh 101, and an intro to computing on, you know, on campus 1-unit class. So no one would look at this and tell you that he's done anything wrong. I think it looks like a fine first quarter. But then if I told you that he might want to go to dental school, anyone who knows the undergraduate courses at this university would tell you that's a huge mistake. You can only take introductory chemistry in the fall. So he missed his chance to get that prerequisite done. And thus all of his other courses are pushed further into his time in college, you know, allowing for less time to take courses for which chemistry is the prerequisite. But you could only give that advice if he already had this goal in mind and he communicated to someone with that specific knowledge. So on the surface, a fine choice, in hindsight, a bad choice. So you can imagine that many students make decisions that aren't fully informed, and then that has very fateful consequences for the availability of certain pathways. I have become, I think, more and more convinced that in order to understand pathways through college, you need to understand the environment of choice that exists upon matriculation. And so it's actually, I think, also surprising that given the potential impact of choice on the college experience and on major trajectory, that there isn't more work being done to really look at choice deeply. And that's what I'm hoping to do, you know, to qualitatively look at how choice works in this context to reinforce inequality in outcomes that are of concern, or that I think should be. The outcomes, you know, that I'm talking about are fairly standard, ubiquitous, and important. We see stratification of both college majors and in the workplace by gender, race, and socioeconomic status. This is a problem because careers that are most stratified tend to have implications for power and economic disparity that largely disadvantages these groups and reinforces gender, race, and class structure. I also think it's important to note that the creation of knowledge through the sciences and in graduate school, tech, and in other domains is an incredibly important place to have diversity of thought and experience. I'm also, you know, happy to get on a soapbox and the Q&A and go into this literature further. So here's the tension that I try to address. One, US higher education is set up to include and virtue choice for students in almost every domain of campus life. However, we know that students bring different dispositions, capital, experiences with them to college, which then opens the possibility of choice being a conduit for perpetuating inequality. So my dissertation focuses on the first year because that's when so many of the consequential choices are made. So finally, I get to share with you how the choice structure in higher education, in this case, with course selection in math can lead to inequality. I'm also happy to share that this paper, Should I Start at Math 101, Content Repetition as an Academic Strategy in Elective Curriculums, was just accepted for publication in Sociology of Education. So more coming soon. I approached this question about choice using a longitudinal cohort study that I co-designed. The accumulation of, so the LCS is a continuing project, and it's aimed at understanding the kind of longitudinal dimension of decision-making and the accumulation of experiences in college. It takes place at a highly selective private West Coast university, which I call Western University. I also have access to 20 years of de-identified transcript and enrollment data at the Case University, as well as permission to access the specific transcripts of the students in our study. And so in the summer of 2019, we opened this study to about half of the incoming frosh. We then attempted to interview these students every quarter, kind of right around that ad drop period. At the end of the first year, we had developed a stable cohort of 85 students. And after this last year, we still maintained an active cohort of 78 students. Interviews ranged from 25 minutes to 2 hours and averaged about 45 minutes. And Western has a very diverse student body, and our sample is actually largely representative of the incoming class from which we draw, with a little oversampling of women and first-generation college students. So interviews were semi-structured, and each interview had some standard questions focused primarily on students' academic plans, their choices, and their experiences. We asked students to talk specifically about each of the courses they were considering and their decision-making process around those courses, their experience in their current courses, and then reflections on prior courses. We also asked about their major, grad school plans, and extracurricular activities every quarter. So at this point, I'm happy to report that we have eight rounds of the interviews complete, most of which are already transcribed and cleaned. We have 621 interviews at this point, and close to 800 expected by the end of this academic year. So safe to say, we have a lot of data for how students choose courses. And of course, a project of this scale requires a team. So Mitchell Stevens is the PI, Arik Lifshitz is with University Advising, and Phil Hernandez is the other PhD candidate on the project. We both share interviews, or do interviews. And a quick acknowledgement to my lab interns. Over the 3 years that this project has been running, I've mentored 12 interns, mostly from Foothill Community College, who participate in a research exchange program and have done work on this project. So this paper on first math classes is focused on the first 2 quarters of the first year. And that's mostly because spring quarter was when all the instruction shifted online due to COVID, and course taking just wasn't generalizable. So of our 85 students in the cohort, 53 of them took a first math class in these 2 quarters. And it's important to point out, math is a very different type of subject. First, it's pervasive in our educational lives. You learn it early, you learn it throughout your education. It's constantly assessed. It's also one of the most prominent arenas for developing racist and sexist ability beliefs. Stereotypes about math pervade our culture and our media, telling us that some people are math people and, some people are not. If you're not familiar with this particular meme, it references when Teen Talk Barbie was introduced and given her first words in the form of a voice box. And one of the phrases it said was, "Math class is tough," followed by, "Let's go shopping," which rightfully provoked outrage. But even now, kids become aware of stereotypes in math as early as in 2nd grade and can develop what's called math anxiety around that time as well. And math is also deeply connected to the literature on growth versus fixed mindsets, people's belief in their own ability to learn. And it's one of the most, I think, internalized stereotypes, and why I refer to it as a cultural schema. And if you need more evidence of its ubiquity, here is an excerpt from Western U's website offering advice on math course selection to incoming students. The advice goes, "Don't think just because one person can skip a math class that you can. Quote, different people have different capacity for learning math." And we see that relationship to math play out in higher education and in undergraduate pathways. We know one good or bad introductory course experience can have a huge impact on how students consider whole fields of study. When students get to college, they're often taking competitive gatekeeping classes like calculus and statistics fairly early in their academic trajectories. And their experiences in those courses often kind of dictate their trajectory and shape their undergraduate pathway. Grades in calculus courses have been shown to affect the likelihood of pursuing STEM majors. And even among those entering with STEM intentions, taking calculus 1 has been shown to dissuade women from STEM pathways at 1.5 times the rate of men. So first math course decision-making and the students' experiences in these courses have the potential to influence undergraduate course sequences, and I think serve as an important contributor to the understanding of STEM pipelines. And the more sociological reasons we should be interested in math course selection are because of who might choose what and when. We know students come in with different forms of capital, and that those with more privilege and resources tend to already know how to navigate the university to their benefit. But when deciding whether or not they might follow the math placement test guidelines, or who might feel empowered to make decisions potentially against university recommendation for their own perceived benefit, we all, who might do that. And we also know that math affinity and course taking are not independent of identity. So I draw on literatures of Capital and Habitus and their modern day interpretations in the sociology of education to explain, what we saw in first math course selection. So by Habitus, I mean like the way a person of a particular background perceives and reacts to the world, ways of being that are accumulated through a person's experiences, upbringing, and, cultural exposure. So now let's talk about how students made decisions when confronted with their 4 potential entry points in math courses. So there's Math 98, 99, 100, and 101, and you can see the corresponding high school course topics underneath. At Western, before enrolling in any math course, all students are required to take a math placement exam. However, after taking that, they're not beholden to its results. So you can then imagine that students sort themselves into the course they deemed best suited for their math level. So if students have basically full control over choosing their first math class, you can imagine that students would enter said course with somewhere between 0 and 100% of that content already covered by a prior math course. So for every course, we ask students, in this class, are you reviewing materials or are they all new? And we noticed that there seems to be more frequency of repetition than we had anticipated. And also that repetition seemed to be focused in math courses. So repeating content is generally considered negative, maybe a sign of stalled progress, a lack of understanding, or at least I think the waste of an academic opportunity. So, why then were we seeing students repeating content? We went back through the transcripts and made an inventory of what we are calling content repetition in math. So there were many instances where we were not able to determine the level of repetition, but the definition of content repetition for this presentation is if we were able to determine that 50% or most of a course's content was a repetition of content learned prior to matriculation for a given student. I would pause for a moment and have you place yourself in the shoes of an incoming first-year student who takes the placement exam and is told that the math department recommends starting at Math 100. Would you personally take that advice? And relatedly, I would also ask, what percentage of students do you think repeated at least half the content of their first math class? So, results. Of those 53 students who took a math class in the first 2 quarters, 24 of those students, or 45%, took their first math class as mostly content repetition. We call them repeaters. And we call those who were new to the content of their first math class novices. And on that spectrum of 0 to 100% of repeated content, you'll notice that the students seem to either be, repeating the course or entirely new to the content. And I will say students at above over like 30% repetition seems to receive at least some of the benefits of content repetition that I'm going to describe here. But those over 50% or reported experiences that were, I would say, nearly identical to those who had 100% repetition. So you might be asking yourself, what might be the differences between those who repeat content and those who opt for all new material in their first math course at Western University? When we looked at the 24 students who repeated content, here were a few things that we noticed. To start, no initial difference in how they felt about math before college. In general, the rates of liking or being anxious about math were the same for both content repeaters and novices. Also, only 2 students in our sample started in the bottom math course that Western has to offer, with it being new material, meaning that most students, 1, were well prepared, and 2, had the opportunity to take their first math class as content repetition. There was also no gender difference, nor any differences in whether the students were planning for graduate school, med school, law school, or collectively any grad school. In terms of racial differences between content repeaters and novices, white students were more likely to be content repeaters, and Asian students were more likely to be novices than their size in the sample would suggest. But here I'm working with really small numbers, so I would not declare that a huge result. It's more just, I think, pointing in a direction. I think the set of factors that seemed to more prominently capture the demographics of content repeaters was actually more to do with cultural capital associated with navigating higher education. So looking at the 53 students who took a math class in their first 2 quarters, the high school background of those students, I think, tells a little bit of a story. So those from public high schools were more likely to be novices in their first math course. However, if they went to public high school and took a college class while in high school, we call that public plus, then their chances of being a repeater changes. And private school students and those who went to private school and took a college class, private plus, were the most likely to be repeaters. And I think this points to some capital that's gained by exposure to college classes prior to matriculation, as well as I think the agency that comes from navigating elite environments like private high schools. Another division between repeaters and novices that we thought was significant, of the 24 students who were content repeaters, most were from middle, and upper class families. Only 3 were from lower middle or working class families. And only 1 of the 24 students was a first generation college student. Again, I think pointing to the role that privilege and experience in institutions of higher education may play in the decision-making process. So then, we wondered, so what are the reasons students are giving for repeating content? How do they go about deciding which first math class to take? Of the 24 students most often used some combination of these 4 reasons. First, they spoke of really wanting to understand calculus before moving on, knowing it was, foundational to what they intended to study, as in this quote. I'm going to be taking Math 100. It's calculus 2, basically. I feel like I need a more solid base in it before I get into higher mathematics, because data science gets into things like linear algebra. So I feel like it's important for me to have a very solid base in calculus before I try and go that far. Some talked about insecurity about their high school or general math education prior to Western University, whether it would match the expectations of college. Some of those were from international contexts. Other students noted that their knowledge was somewhere between 2 courses that Western U offered. And so even if it was only 2 weeks of content that they were missing, they wanted to cover those topics before proceeding. And some talked about the transition to college. They didn't want to be overwhelmed by courses and have time for socialization and adjustment. So Clark says, Math 98 is a little slow. I probably maybe should have gone into Math 99, but my first quarter, I don't think it's too bad of a thing to have a class that I will not be stressing about all the time. And perhaps you're curious about the reasons students cite for not repeating content. What may or may not be surprising to you is that novices actually very rarely discussed content repetition as even an option. It was just naturally defaulting to the next course. You take for granted that this is how the system works, and they never reported any contemplation of content repetition. Some cited that they took the class in which they were placed by the placement exam. Others talked about not wanting to waste time or credits in classes that were mostly repetition. And I'll say here, this is why we invoked the idea of habitus in this study. Not one of the repeaters cited anyone telling them to do this. Any advice they'd seen, or any knowledge about the courses in particular that influenced their decision. I was thinking, really any form of social capital. Instead, it seemed more of a disposition. They didn't take the placement exam too seriously. They evaluated what they thought was best for them, given their own preferences. And also, they didn't relate repeating a course to any sort of failure. In fact, the only 2 instances of advice that we saw were in favor of being a novice. So Alma, who was a first generation college student, reported being encouraged by her mentors in a program for first generation college students to challenge herself in her coursework. Their advice made me realize that I needed to be spending all my time valuably. They talked about choosing classes, and they were talking about how a lot of people tended to go to their comfort zone, like, oh, I covered multivariable calculus in high school, so I'm going to go straight into Math 101 and nothing else, and not want to grow. They taught me to put myself out there and take risks with my classes because I have to learn eventually. I think I wanted to be comfortable where I was at. I considered taking CS 101 because I already knew how to code. I would breeze through in that class, and I considered taking classes that would make for a good, fun quarter. And then I guess they made me realize that I'm not necessarily supposed to be here for a good, fun quarter. I need to be moving forward and fulfilling requirements. So Alma ultimately opted for a course covering material that was entirely new to her, though her inclinations mirrored that of the content repeaters. So in subsequent interviews, Alma told us that she felt like she was struggling from day one in the course, and she spent all her time studying. So which brings me to the so what. So what if these students repeat their first math course? This study is unique because we're able to track the students in each course, those who did content repetition and those who did not, but were in the same courses as those who did. And probably surprise, surprise, they had vastly different experiences. Even more, their experiences were often dependent on the other. So let me start by first naming the differences between repeaters and novices in their experience of these math courses. For those who did repeat content, we noticed mostly benefits. Among these, they tended to get higher grades, develop confidence in mathematics, and tended to engage more in college life. They spent significantly less time than their peers in office hours, sections, tutoring, and on problem sets. So this is in contrast to the novices who were in the same classes taking the math content for the first time. They tended to have lower grades and spend more time with their support services. And these students tended to doubt their ability in math and doubt their STEM pathway overall. For the sake of time, I'm going to take a selection of these findings to share with you so I can give you, a deeper dive into the qualitative data. First, in terms of confidence, repeaters often reported a boost to their confidence after taking their first class as repetition. Here, Olivia says, it helps me to decide that I would take another class from that same professor, and it made me feel more confident about math class this year. And in a different interview, I asked Blake, so you've had a lot of camaraderie? And he said, yeah, I was also able to help people if they were struggling and I understood the material. So that was a nice experience. So being relatively more knowledgeable made these students more confident, have better experiences. This is a repeater who discusses that the pace was fine for him. I feel like it's going really smoothly, or it feels like it's just the right pace. So it's not too fast, but it's also not too slow. We're covering enough content, but not too much where we're being overwhelmed with the material. So I think the pace is really good. I mean, it's going to get harder as the quarter progresses, but so far the pace has been very good. And I asked, are classes generally what you expected, or have you found anything surprising thus far? Not really. I mean, maybe Math 101 is a little bit less work than I was expecting. Maybe it just got a bad rap. I mean, and it's definitely a significant amount of work, but I think it's just blown out of proportion. I mean, I don't go to math, and this is actually a little later on, he says, I mean, I don't go to math section, but if I did, I'm sure it'd be great. And so he goes so far as to say that, the class he's repeating just has a bad rap, not realizing that his experience is probably not representative of others' experiences. 80% of this course was review for him. And so I want to reemphasize that what was, kind of wild about the novices and their experience is the performance in the class and their affective experience of the class. Both of those were often dependent on the repeaters in the course. So having many students in those courses that had already taken the material led novices to kind of calibrate themselves against those peers. And they tended to have, self-doubt around their abilities in math and in STEM more broadly. They tended to blame themselves for not studying enough. And many identified that they felt isolated from the peers in the class for whom math seemed to come so, in quotes, naturally. They also spent a ton of time on these courses, time not spent socializing or participating in other extracurriculars. So here's an example. That class definitely kicked my butt. It was definitely very hard. I did IB in high school, and I'm not sure if the reason it was hard is because the classes I took were different than AP classes, but I was talking to some kids who say, yeah, we don't know all this stuff, but some of it is review. And I thought, oh, I have no idea what any of this stuff is, but I got placed into it. So I don't think I was stretching too far, but it was definitely a wake-up call for me. In this case, the placement exam put her in the class, but she was still at a relative disadvantage. And this further comparison between students is from VJ, especially in Math 101, a lot of them have taken a multivariable and a linear algebra class before. It feels like while you're learning this for the first time, they already understand the gist of it. Their main struggle is trying to figure out what the problem's asking. They already have all the tools to solve that problem, where I'm still developing those tools. For me, I mostly just found students from a similar high school background to me and worked through building those tools first before attempting the problems and the concepts. I think that definitely helps it to be more approachable and less intimidating. And then all the other classes, people generally are from the same level of knowledge in those subjects, so I don't really have trouble talking to people in those. So you'll notice that the difference in exposure to content led this student to self-segregate with others from the same exposure and feel at a disadvantage to others. You'll also notice that for this student, math was the only subject where this was really an issue. And just to kind of summarize the novice experience, I thought this quote from Sophia was perfect. And now I'm super miserable because I don't want to be in this math class because it's way too hard for me. But I also really don't want to drop it because math is my thing and I love math with all my heart. But I feel like there's no class that is both hard enough and also doesn't take over my life. So one thing that happened to me last quarter is that I really lost my confidence when it came to math. And this was a student in honors math. So as of now, students in this study are still in the midst of their second or third academic year. So I don't have any outcome data on their degree or career choice yet. However, we saw indications kind of similar to the last quote that their experience in their first math course had an impact, if not in degree choice, then per se, then at least in affect. So here's a quote from Linda. I don't think I could solely do a humanities major anymore. I don't think I could do that. I might still want to study comparative literature, English, or something like that, but I wouldn't just study that on its own, just because I'm enjoying Math 101 so much this quarter, and I think that's where my strengths are. So you can see the potential advantage that content repetition can bring to students. And we also can see the opposite. The effect of being in these courses with repeaters has an impact on their confidence and also their trajectory. Amelia says, I'm struggling in Math 98, and there still is Math 99 and 100 and Math 101 in a major where there's a lot of math involved. Is that really what I want to get myself into? So I'll end there for my quotes, but I want to say thank you for being patient while I read all those quotes to you. I think what I can kind of summarize is the demographics of content repeaters tell us that it's those with relative educational privilege and familiarity with navigating higher education that engage in the practice of content repetition. Most not with the intention of gaming the system, but rather with a desire to do what's best for them and their learning. I think the findings presented here have important implications for both math courses and STEM pathways, as students with advantages are accumulating more advantage through the process of content repetition and at the direct expense of less privileged students and their STEM pathways and self-confidence. There are also pretty severe implications for methods of evaluation. Any grading curves that directly compare students are going to be highly skewed in favor of content repeaters and disadvantage first-timers in ways that will, I think, detriment the diversity of the entire STEM pipeline. So it brings up the question of, what types of interventions might make for more positive experiences in first math courses. So if I ran the world, or at least, the university, here are a few things I would consider that I think are natural extensions and applications of this work. First, grading curves are terrible. There's no way any curved assessment gives novices and repeaters equal chances. And by design, it tells students where they fall relative to their peers rather than how much of the content they've mastered, which can be extremely misleading and discouraging if there's a significant number of content repeaters in the class. Second, the pace and the instruction of the course should be aimed at the novices. All too often teachers, teach to the middle. And in our case, we found that the middle is way too high. I wasn't able to show the quotes here today, but novices are spending so much time trying to pass these classes. Office hours, sections, tutoring, sometimes multiple organizations that do tutoring, additional sections, study groups. It really impacts students' ability to engage in college life, especially in the first 2 quarters of their college life. And extracurriculars, et cetera. And I think also, given the benefit to confidence, I think more math programs should design courses with the explicit intent of repetition. I don't think the message you should walk away with is that content repetition is a bad thing. There's a lot of advantages to it. Content can be, taught quicker. Students can adjust to the way college math is taught. It can boost their confidence, ensure that their prior instruction was comprehensive. And lastly, I think the lowest hanging fruit is really just to ask math students about their prior experience. I find that math professors often don't even know who's sitting in the classroom and what prior experience they bring. I think math professors would start to see the ridiculousness of a grading on a curve if they start seeing how many students come with significant preparation and engage in more kind of course redesign aimed more at the novices in their courses. Lastly, I think I said lastly twice. So as with so many things in the first year of college, I think knowledge is power. If students are more aware that content repetition is a valid choice with significant benefits, more can, then consider it. And I think more can engage with it. And for those that don't, at least they'll be aware of the environment, when they're entering a given course. And perhaps it would take less of a psychological toll if they're aware of the unequal footing that they enter with. I would want them to walk into a class and see their relatively low performance, not as a personal weakness or a lack of fit in STEM, but rather what is an initial disadvantage that has nothing to do with their capacity. And of course, I also want to mention some of the things that make Western University unique. One, because it's a highly selective university, most students came in with at least some calculus, and that's not always the case. Second, I think the quarter system makes it less costly to repeat content because there can be more courses taken per academic year. And third, students don't pay by the credit. Thus, it takes away the actual cost of repeating coursework. But for me, that means that the next steps are to look at different types of institutions and to understand like the role of choice in math and in other areas. And I thought it was apropos to show you what I found when I did a little digging about the math courses available to Frosh upon admission here at Michigan. And this website is for Frosh, doesn't even count the remedial pre-calculus math courses that are available. So there's the standard calculus sequence, the applied honors calculus sequence, the honors seminar math sequence, the honors calculus sequence, and the honors math sequence, which are all different courses. So the website makes clear you should consult with an advisor before deciding which course to enroll in. So there's a lot, I think, even here on your campus to disentangle about first math course selection. So thank you so much for having me here, and I look forward to hearing how you're thinking about this and other implications of this work I should consider going forward.
That was wonderful. Thank you so much. Okay, so we do have some questions coming through the Q&A. Gus Everard has a question. Have you communicated your findings to the math department, and are they amenable to changing the recommendation process to support novice learners?
I have not shared my findings, as I was given advice to hold off until I really had potentially a publication or some kind of more specific things to build on for the department. But I look forward to doing that. It's one of my goals before I leave.
Do you have any thoughts about how you anticipate they'll be received?
I think it's always hard to hear critiques, but I actually think that the math department here has been very open to changing their structures, especially in the last few years. They've wanted to be more inclusive and wanted to create more opportunities for people to not only pass through the calculus sequence with ease, but also to stay within mathematics. And so I think that they'll be very open.
Awesome. Yeah, Mitchell's chiming in that he's a little less optimistic. So Rachel Niemer has a question. I can imagine that concern about time to degree and therefore financial cost of degree could contribute to a decision to repeat content or not. So even though you're not paying per credit, it could potentially extend the number of quarters that you need to spend. How does the LCS data support or refute that hypothesis?
Yeah, so there's a really generous credit per quarter, because you pay tuition and you get a significant amount of credits. You need 15 per quarter to graduate. You get 20, or I think 21. So an extra course per quarter that to kind of play with every single quarter. So I don't think that it directly impacts degree completion in that way. The way I do think is that students at Western University now push themselves to get 20 units a quarter so that they can also get a master's degree before they finish in 4 years, because it's covered by financial aid. If it's past the 4 years and they want that master's degree, they have to pay tuition. And so it doesn't come in the direct way that you're talking about, that it's progress towards degree completion in 4 years. It actually has taken on this other form, which I think really tells us that giving students more credits does not solve this problem. There will always be another problem as students try to get the maximum kind of benefit from their credits.
Okay, so then two like sub research questions about whether or not you've cut the data this way yet. Have you looked at achievement and satisfaction through how many credits they're trying to jam into one quarter?
Yeah.
Or by their math placement score?
I haven't. So I don't actually know what their math placement score was, because this is something that we kind of retrospectively said, hey, this seems like it's a thing. So we didn't actually ask specifically, what was your math placement score, even though everyone who took a math placement test got one. So we didn't ask about that. The second part of your question was about degree.
Oh, yeah. So like, how many credits are they taking each quarter that they're trying? Like when they're a novice learner, how many credits are they trying to take? And does that change the difficulty perspective?
Yeah, like the idea being that you would take more credits if one of them's an easy math class to you.
Yeah. Right?
That's a great hypothesis. I have not looked, and that's something that I will definitely look at. Does that make sense? Is that maybe novices are taking more or fewer credits because they know it's going to be hard, and content repeaters are taking more because they know it's going to be.
Or maybe they don't know and they're taking too many credits to actually be able to engage with the amount of time that learning takes, right?
Yes, I agree with that. I think that that one of the future studies down the road is just who has regrets and what are those regrets about. Because I do think that the people who are regret things, like June in the example I gave, regretted not taking chemistry in the fall of his first year. I do think that some of the students regret taking the math class when they did. Although many students did not think of it as an option. So they have no way to regret because they never considered it. They still don't consider it an option.
Yeah. Okay, so Rachel's got a follow-up, and then Becky Matz has a question in the Q&A as well. So Rachel's question is, following up on the master's degree comment, do students report wanting to graduate early so that they can pay less tuition overall?
No. We don't see that like in our data. They could be different, students feel differently, but most people embrace the 4-year experience and then basically try and squeeze into their 4 years this 5th year of a master's degree. That's at least the culture here on this university. I think that's very different in different contexts. So that's something that I think on different campuses, the vibe about graduating early, also because the financial aid packages are so robust at this university, and they cover 4 years of a very generous credit unit, and often cover housing and books and are pretty robust packages. There isn't much talk about graduating early for financial reasons.
Fascinating. I definitely think that's going to end up differing by institution. Okay, and so Becky has a great question. What's the worst that could happen if universities disallowed repeating courses that students had already passed, whether in high school or college?
Yeah, so I think I think it's a little bit of like this instinct to control that we just are like, don't do it. But I think that the worst thing could happen is that you'd actually have fewer people on STEM pathways, because some students reported that they took, their AP calculus their sophomore year, or BC calculus, or linear algebra their sophomore year. They're so ahead. And so they wanted to repeat content that they took 2 years ago or 3 years ago. And like that kind of actually seems valid to me, is that, yeah, you did take the content and it's on your transcript that you took it. But like I think until you can solve the problem of math instruction, it's really hard to prohibit repetition. Until courses are actually adequately allowing students to transition from high school to college and learn the content and also adjust to college teaching in a reasonable way that is true to the credit hours that they are being allotted and allow for success, then I think the worst thing that could happen by mandating someone not repeat is that you just would really lose a lot of students to both STEM pipelines and I think in math. And I honestly in other pipelines too, because majors like econ require math as well, and so even people might get very discouraged on their math pathway to be able to major in things that aren't even STEM.
Yeah. Okay, Nick, you've got your hand up. What is the route for you to ask a question? I'm not sure if that would be best in the chat or if you're actually able to speak. Oh, brilliant. Look at that. Magic.
But you're muted.
There you go.
I don't think I put my hand up. Sorry.
Oh, no worries. So maybe you don't have a question.
That's fine too.
No worries. Okay. Okay. If you imagine a sliding scale between the success of content repetition primarily being sort of the campus confidence, right? Like you're locking in what you already know, you're settling into a first semester at a competitive institution. That versus maybe you didn't know what you actually thought you knew. So like actually like learning a whole bunch in a course you thought would have been too easy for you. Or really just the sheer difficulty of engaging in new math content. Which of those do you think is more responsible for the outcomes that you're seeing of success through content repetition?
Make that list again.
Sure. So the utility of just going through something again, right? You know it, you've learned all of this, you're one of the 100% people, you have actually seen all of this recently, you do know it, but it's really valuable to feel confident about something, see it again, get it in the campus context, right? Or maybe you thought you'd seen it, but you actually didn't know a good chunk of it, and that repetition actually was new, it just isn't labeled as that.
Mm-hmm.
Or that new math content is just really, really hard. And like the negatives of addressing something in a new space are far outweighing the benefits of seeing something again.
It's really hard to disentangle those. Yeah, I think I would, now I realize the extra slides I should have prepared, because one of them is the grade distribution, and you see that there were many repeaters who were taking it for 100% repetition sometimes that really struggled. They still got to be in the class.
Okay.
And I think that speaks to the adjustment to college teaching of math. And I think it speaks to they were underprepared potentially, like that the class didn't translate, even though they covered the content, they didn't really learn it or they didn't understand it. I also think I would challenge that new math content is really hard. I think math instruction in college makes math content really hard. And I think that that's a component that's really what has to get fixed, is that like math is a beautiful subject, and that if we could make it so that novices in a course can take the course and feel successful in that course, with all new content, then I think we would be kind of more successful. But in terms of which factor, really hard to tell.
So I'll reframe the last point to be that I actually think new learning is really hard, like actually engaging with any content area that's truly new to you. I think we disrespect how hard that can be sometimes, right? Yeah. Not exclusive to math. I really love that point. Gus has a great point about how B is now a failing grade, yes. Right? And that's really hard and really true in a bunch of spaces.
Yeah, that is very true.
Yeah. Okay, I had one detailed note. Have you looked at the trajectory of students who have stepped away from the study? Is there anything to be like, should we be thinking about who we're not hearing from in these conversations at this point?
Yeah, we had really great retention. We had 103 initial participants to 85. And there was no particular demographic that we lost in that first year. And I think so that I don't think that there was any kind of voices lost. Well, we have underrepresented or kind of privileged white students who had very different experiences than students who came from low-income backgrounds or were first-generation college students. So I think if we're trying to make colleges more inclusive places for first-gen students, for students of color, this would be a mechanism to do that.
Rachel's got a question. how might the quarter system and the pace of those courses move at relative to a 14-week semester course that covers the same amount of content play into the value of repeating content?
Yeah. Well, like I said kind of before, just when you have a quarter system, you have so many more chances to take courses. So the cost of repeating a class doesn't take up an entire half of a year of your first undergraduate year. So I think that definitely makes a difference. I also think you could spread it out differently, right? I think it's the same total number of weeks over the course of a year to learn calculus A, B, and B, C that it probably would be to take 2 semester, course, but it's broken up differently. I think that would be a really fascinating comparative case of what content repetition looks like in quarters versus semester systems. Mm-hmm. By virtue of the semesters potentially making longer content, because there's still just, rather than 3 quarters and 2 midterms and a final exam for each quarter, maybe there would actually be fewer examinations and then more time for content. That could be a potential way that the quarter and semester system differ. But that would be fascinating how students perceive the risk of repeating content on their kind of future trajectory.
Yeah. Okay, so we have sort of 2, almost moral questions. Should we be recommending students to repeat more? And it seems like the conclusion is potentially yes. And then the one we haven't talked about is, does this actually encourage us to offer students less choice?
Yeah, that is a great question. The first question, yeah, I would recommend, until you can fix the system, the benefits to repeating, I think, greatly outweigh the progress to degree completion. Like if it's about your confidence in math when you approach, when you arrive on campus, like that's really invaluable to me. Like if you have to pay for 5 extra units at the end of the day, that was probably worth it if you feel confident in your STEM pathway. Like, in the long-term scheme of things. Now, will one course that makes you feel more confident, actually lead to retention in STEM? I don't know that answer, but that's my inclination. The second part of the question is, do you limit the number of choices? Yeah. Well, I think it's just about quality. Is that like, I think it makes a lot of sense to offer repetition courses that go at a faster pace, that allow you to take content that was repeated. That's if I could run the world, that's what I would do, is have a specific course that allows students to kind of go on a faster track by design. I also think, though, that as long as grading curves exist, you're going to want students who aren't just there for the content. They might be there, and I will say not many of our students were talking about grades as the reason, but as long as grading curves exist, there's an advantage to being in a lower class, and there's a disadvantage. And I think it's mainly the disadvantage I'm talking about to novices. And I think that if you think about this not through the repeaters lens, but through the novices lens, like what's best for novices, it's having a course that takes them from the beginning of the content to the end of the content at a proper pace, and like doesn't compare them to students who already have that content.
Fantastic. Okay, any last questions? Otherwise, I will invite everybody to thank Monique for such an awesome conversation. This has been just wonderful.
Thank you.
I love how many questions have surfaced. Really, really appreciate you contributing this. It's such great work. And so excited about the publication. Congrats on that.
Thank you so much. This was great. I really appreciated the chance to be able to chat about this. And anyone ever wants to contact, I would be happy to talk more about this.
Wonderful. Okay. Happy Monday, everybody.